two more topics left to wrap up fiber optics: temperature sensors and Mach sensor. So temperature sensor is very simple. You have your normal fiber optic cable, your core cladding and all, and at one end you fix two strips of metals. The yellow color and the blue color here in the diagram, they represent two metal strips. Each one is a different metal. Now ideally under normal conditions, it's a temperature sensor, so obviously we'll be applying heat and all that, but let's assume I'm not applying any heat, there is no change in temperature. What happens is I shine some light here, it travels, TIR happens, it hits both the metals and it comes back. So normally it will hit both the metals together as one ray and come back. So you have one incident ray and one reflected ray coming back here under normal conditions. Now when I change the temperature, it could be applying heat or cooling down, but we'll assume we are increasing the temperature. It works just the same way for the contrary also, but let's say I'm applying heat. Because these are two different metals, they will expand to different extents. Metals, they expand when heat is applied. So the yellow one will expand to a certain extent, the blue one will expand to a different extent. So when your light wave comes here, one part of it hits the yellow metal and gets reflected. The other part penetrates, it goes, hits the blue metal and gets reflected from there. So now you have two reflected waves which are at different phases. So an interference pattern is formed, and that is what you get back at this spot. You get two waves at different phases. So depending upon the phase difference between the two output waves, you will identify the temperature change which was applied. That is how a temperature sensor basically works.